So in the last lesson, we had a look at how we could compare fractions which have got different denominators, and we saw that we could use a number line to help us do that. In today's lesson, what we're going to look at is how we can compare the values of fractions with different numerators and denominators where you're not drawing out a line, so we need an alternative um, excuse me, method to try and work this out. So by the end of today's lesson, I'm hoping that you will be able to compare fractions. We will be using previous knowledge of working with mixed numbers and improper fractions, and to be able to change in between the two of these. So we saw in the last lesson it's quite easy to compare fractions when the denominator is the same. If you were asked if somebody said you want 3/5 or 4/5 of a pizza, hopefully you know that the bigger version there would be 4/5. Now, something that I'm going to introduce you to is these little symbols, the less than and greater than symbols. You may or may not have noticed them on your keyboard on a laptop or a computer. So the way to remember which way round these two little, almost like two sides of a triangle type symbol, are that the smaller end, so the pointy bit always points to the smaller number. So the 4/5, we can say here, 4/5 we could write in words is greater than 3/5, or we could use this little symbol that says 4/5 is greater than 3/5. If the symbol was the other way around, for example, we could use it to say that 3 is smaller or is less than 5. So the pointy end pointing to the smaller number. So if we look at another example, so what we've just said there, it's easy to compare fractions when the denominators are the same. If the numerators are the same, right, relatively speaking, it's easy to compare as long as you can remember that the bigger the denominator, the smaller the fraction. So what I mean by that is, if you visually think about this, so bar of chocolate, divided it up into 4 pieces, each piece is a quarter. Take the same bar of chocolate, divide it up into 5 equal pieces, each piece therefore being a fifth, and with a bigger number on the bottom of that fraction means that actually the smaller is a smaller fraction. So a fifth, even though the 5 is a bigger number than 4, but in fraction terms, a quarter is a bigger fraction than the fifth. So if you were comparing which fraction is bigger, 3/4 or 3/5, knowing that the quarter pieces are bigger pieces, I'm sure you'd rather have 3 of those than have 3 of the fifth pieces, so 3/5. So 3/4, right, we can clearly see is greater than the 3/5. So visually, you can think about if you were drawing out little diagrams like this, but we're looking for an alternative method without the line. So it becomes a bit harder when the bottom numbers are totally different from each other, the top numbers are totally different from each other. So what do we do with ones like this? So we're going to run through a little PowerPoint here, take you through some statement with this. So if we were saying which one is smaller, would you rather have a half or a third of a cake? Hopefully you know that the third piece here, as we've just said, would be smaller and so on. So thinking about these, right, it is sometimes easier to think about it. Half of a pizza is bigger than a third. If you're comparing halves and 2/3, again, it's relatively easy to think about the half a pizza being smaller than 2/3 if you did that visually with a diagram. 7/8 or 2/5, your 7/8 is clearly more than half, whereas your 2/5 is less than half. So in this case again, it can be easy to sort of think about which one is bigger or smaller than the other one. With 3, 6 or 8, 9, 3, 6 is the same thing as a half. We've spoken about equivalent fractions before. Whereas 8 ninths is almost a whole, so clearly that one would be bigger than the other one. And the 1/8 or 7/8, right, again, that's quite easily to see. 1/8 would just be 7 pieces of a pizza. If you divided a pizza up into 8, that would only be 1 bit, whereas 7/8 would be 7 times more, so clearly it would be bigger. So sometimes it can be easy to work out. However, right, sometimes it's quite tricky to actually tell. So with these ones here, both of these numbers, 2/3 or 5/7, which is bigger, both are a bit more than a half. 2/5 or 3/8, these are both a bit less than a half. 7/9 or 4/5, again, they're more than a half. And 3/11 or 2/9, you know, both are quite small pieces. And 4/7 or 5/9, both are a bit more than half. So what we need to do is find another way. So it's not a case of guess and hope for the best. We can actually compare the two fractions. So here's a way that we can compare them. And way back in one of the first lessons that we did on fractions, we spoke about equivalent fractions. So if we were writing down 2/3, we can also write it as 4/6. So if we were comparing 2/3 with 5/6, for example, then if you change into equivalent fractions where you've got the bottom numbers that the same, you will be able to compare. So we are going to be using our equivalent fractions to help us. So here, if we're comparing 2/3 and 5/7, right, we have to change them so that the denominators become the same. So how do we do that? So this is us using our equivalent fractions, and something that we need to remember about is something called common multiples. So what I mean by that, well, common multiples are going through your times tables, right? All you need to do is look at the two bottom numbers. In this case, all the multiples of 3, so that's your 3, 6, 9, 12, and so on. If we also look at the multiples of 7, your 7 times table, 7, 14, 21, and so on. So the first number that's in the same, in both of those times tables would be the number 21. So we say the lowest common multiple is 21. So what we'd be doing is, right, we use this LCM, standing for lowest common multiple. It means it's the first number that's in the 3 times and the 7 times table. So how do we get the numbers on the top for this? So remember that what are you doing to the 3 to change it into 21? So we're basically times them by 7. That means that we're going to have to times the top number by 7 as well. So we end up with 14 there. Whereas the 5/7, changing it into 21, what have we done here? We have times by 3 top and bottom, so we get 15 over 21. So now that we've been able to write these two fractions in a different way, we can now compare them, and we can now clearly see that the 5/7, therefore, would be the bigger one. So now it's easy, right, to see which one is smaller or which one is less than the other or bigger than the other one. So you could write down that 2/3 is less than 5/7. So by comparing, getting them to be in the same denominator, we can compare our fractions. So going back to the answer here, we've just seen what that is, and there we're now going to have a look at some examples ourselves, and this I would like you to be copying into your jotter. You can pause this as you go through it. So if you were asked which of these two fractions here is greater, 7/9 or 5/6, The key thing is we need to make the denominators the same before we can actually do the comparison. So lowest common multiple of 6 and 9. We'll be looking for you to go through your 6 times table. So I've got it written out here, the start of it, 6, 12, 18 and so on. Your 9 times table, 9, 18, 27 and so on for that. So we'll be looking for you to know that you, or hopefully spot that 18 is common to both of those times tables, and it's the first number that's in both. And what that tells you is that you're going to be changing these two fractions into 18ths. So we're going to put 18 on the bottom, and what we're doing is, if you have a look at this, in order to change the 9 into 18, that would be timesing by 2. But if you times the bottom by 2, you also need to times the top number by 2. So this is 14 over 18. So 7 nines becomes 14 over 18. On this side, to make the 6 change into 18, we would be timesing by 3. So we would also need to times the 5 by 3 as well, so that we would get 15 on the top there. So clearly, once you've done that, you can see that 7 nines is the same as 14 over 18, and your 5, 6 is the same as 15 over 18. Now you were asked which one of these was greater, so hopefully you can see that the 5, 6 is bigger than the 7 nines. So in terms of writing down your statement, you'll be looking to pick the correct symbol, and the correct symbol is this here. So 5, 6 would be greater than 7 nines, and that would be your statement. If it involves mixed numbers and you're having to work out how they compare, then you need to change them into top-heavy fractions. So to do that, I'd be looking for you to say 1 times 1 3/4, you do whole number times bottom number. 1 times 4 is 4, add on the 3 means that we're looking at 7/4. This one over here, 1 times 8 is 8, add on the 7 means we've got 15 over 8. So the two fractions that we're comparing are 7/4 and 15/8. If we're then looking for the lowest common multiple of the 4 and 8, here the first number that's in both the 4 times and the 8 times table is actually 8. So we don't need to change the 15 over 8. We do, however, need to change the 7/4, and to do that we should be recognising it means times in top and bottom of our fraction there by 2. So 7/4 is the same thing as 14 over 8, and then you can compare the two fractions that you've got there. So which one is bigger? You can hopefully see that the 1 and 7/8 would be bigger. So you could write down, if you were using or kept the numbers in this order, this one here is smaller, so you would be using that statement there. 1 and 3/4 is less than 1 and 7/8, or you could write it the other way round. Right? You could also write 1 and 7/8 is greater than 1 and 3/4. You don't need both of those, you would only need to have one of them to make sure it was correct. So you're now going to practice this technique of comparing fractions by changing into equivalent fractions where the denominators are the same. Remember, as soon as you change your denominator, you also need to change the numerator by the same scale. And you should be looking for the to make the denominators the same, you need to be looking for the lowest common multiple.